let's move on to taking a look at the dermis. The dermis is the layer that's deep to the epidermis, so further towards the inside. And the dermis is made of connective tissue. This connective tissue contains a lot of important structures, including the blood supply that supplies the dermis as well as the epidermis, the nerves carrying signals to and from the skin, and a lot of these accessory structures such as the hair follicles and the glands. It also plays the important role of connecting the epidermis to the deeper tissues to make sure that we're holding the skin on to the rest of the body. The dermis itself has two layers. We have what's called the papillary layer of the dermis, directly below the epidermis, and the papillary layer of the dermis is made of areolar connective tissue. Remember, that's a loose connective tissue with lots of room for blood vessels, nerves, and cells, like white blood cells, that provide another layer of protection against infection if anything gets past the epidermis into the dermis. You can see from this picture that the papillary layer of the dermis is not flat. We don't just have a flat connection between the epidermis and the dermis. Instead, we've got these ridges of the dermis, and the epidermis follows those. These extensions of the dermis up into the epidermis are called the dermal papillae. The dermal papillae have a number of functions. First, they provide a better connection between the dermis and the epidermis. If the dermis and the epidermis were flat against each other, that's not very much of a connection, and they could easily slide against each other, and you could actually pull your epidermis off a little more easily. Because we've got these extensions that the epidermis sort of fits into, that gives us a stronger connection, so it's harder to separate those layers of skin. It also provides an opportunity for blood vessels and for nerve endings to get closer to the surface of the skin to improve temperature regulation with those blood vessels and sensation through the nerve endings. The last thing these dermal papillae does for us is it produces the fingertips. So if you look at the tips of your fingers, you can see the little ridges there. Now, most of us know that these are useful for identification because everyone has unique fingerprints. But the real function of them is as friction ridges. That's the other word for fingerprints, is friction ridges. And they give us a little bit better grip when we're holding things with our fingers than we would have if our fingertips were smooth. If we go down a little bit from that papillary layer of the dermis, we get to the reticular layer. The reticular layer of the dermis is made of dense, irregular connective tissue. Collagen bundles going in all different directions, and it provides strength to the tissue in all directions. It's this layer that connects to the deeper layers of tissue underneath the skin. Because the dermis is responsible for providing the blood supply to the skin, there are no blood vessels in the epidermis, the conditions in the dermis can also provide some clues about someone's health. The conditions of the dermis affect the color of the skin, and we can see that and make some inferences about what might be going on. So let's consider a couple different situations that will affect the skin color. The first is cyanosis. Cyanosis is when the skin color looks blue. Cyan is a blue color, and cyanosis means your skin looks bluish. Cyanosis is the effect of low levels of oxygen in the blood in an area of the dermis. When there's not enough oxygen in the blood, that changes the color of the blood a little bit. It doesn't make it blue, it makes it a little bit of a sort of darker maroon, but it does change how the light is reflected from the blood, and that gives the skin a bluish cast. We see this sometimes if a person is suffering from respiratory problems. If a person isn't exchanging enough oxygen in their lungs, then their skin can take on a bluish cast. We see this sometimes when circulation has been stopped to an area. So if you were to tie something too tightly around your finger, the skin is going to begin to look purple and then bluish from a lack of oxygen to that area. And we sometimes see this as a result of cold temperatures. As a lifeguard back in my much younger days, I used to see kids who would swim in terribly cold conditions, and eventually I'd have to pull them out of the pool because I could see that their lips and their nail beds had gone bluish. And that's because they were so cold, so much vasoconstriction was happening in their skin, they didn't have adequate circulation, not enough oxygen, gave their lips and nails a bluish cast. A second condition that we can see is erythema or erythema. Erythema or erythema is red color to the skin. This is caused when the blood vessels to the skin dilate and bring a lot of blood to the dermis, and then we can see that red of all of the extra blood in the dermis. And there are a number of different things that can cause this dilation of blood vessels, including a warmer body temp. Your body temperature rises, we dilate, your skin looks more red as it's releasing more heat by bringing more blood to the skin's surface. This can also happen as a result of emotions. When we blush, that's the dilation of blood vessels in the skin that causes the change in the skin color. And it's also a common result of some sort of infection or damage to the skin. When there's some sort of infection or damage, the body responds with a process of inflammation, which dilates blood vessels to bring in more blood and more nutrients to heal the damage or to fight the infection. And the result that we see is a reddening of the skin. Pallor, or pale skin, is basically the opposite of that. In pallor, the blood vessels are very constricted, bringing less blood to the skin, resulting in a lighter color to the skin, a pale color. This can sometimes be the easiest to see around the lips, where we have a lot of blood vessels really close to the skin, giving a very red color, and as those constrict, the lips can get very pale. Pallor is sometimes the effect of cold body temperature, so as the blood vessels constrict to retain heat, the skin gets paler. It can also be seen in cases of shock. When the body is in a state of shock, a lot of the blood vessels constrict in order to keep the blood pressure up and to prevent blood loss, and that can cause pale skin. Illness, anemia, and blood loss are other situations that can reduce the flow of blood to the skin and end up with the condition of pallor. Another condition is jaundice. Jaundice is yellow skin. The skin looks yellow because there is too much bilirubin in the skin. Bilirubin is a natural breakdown product from red blood cells, and it's usually cleared out of the body by the liver, which stores it in the gallbladder, and then it's released into the digestive system to be removed from the body. But in cases of either liver dysfunction, where your liver doesn't work properly, or if you're breaking down a lot of red blood cells at once due to some sort of exposure to a damaging chemical or an illness, there's too much bilirubin for the liver to take care of, and those elevated levels of bilirubin lead to jaundice, to the yellowy looking skin. One thing I think is interesting is that jaundice is not actually dangerous in adults. Having a high level of bilirubin as an adult doesn't actually cause any problems of itself. The issue is the underlying condition. Jaundice, high levels of bilirubin won't hurt you, but liver dysfunction definitely will. So jaundice is an important symptom of a dangerous underlying condition, whether it's excessive blood cell breakdown or liver dysfunction. However, in infants, the high level of bilirubin itself is problematic. High levels of bilirubin in infants, because their brain barriers aren't fully developed yet, can get into the brain and affect development. Unfortunately, jaundice is quite common in infants because they have just experienced a traumatic event through birth, and their livers aren't functioning fully yet, and neither are their digestive systems. So a lot of newborns end up with a touch of jaundice, and health professionals want to make sure that that's adequately treated to prevent problems with the development of the brain. Thankfully, there is a pretty easy way to take care of bilirubin in the blood, and that is UV light. UV light through the skin can break down bilirubin in the blood. So they often will put little ones under what's called a bili light, or wrap them in what's called a bili blanket that exposes their skin to UV light to get the levels of bilirubin down. The last layer of the skin is not even technically part of the skin, but we learn about it as part of the integumentary system because it is associated with the skin, and that is the hypodermis. The hypodermis is the layer of adipose tissue that connects the dermis to the underlying muscles. This is also called the subcutaneous fascia, meaning which means the connective layer underneath the skin. And it plays the role not only in connecting the skin to the muscle, but also in storing energy, because it is adipose tissue, and providing insulation so that the conditions outside the body don't have such a dramatic impact on the temperature deeper inside the body.